Yes, welcome. My name is Stefan Scheidt. I will talk about design patterns for JavaScript web applications. First of all, my spoken English is not that good, but I hope it will work. So I beg your pardon for any mistakes I make. Feel free to correct, but I hope it will work. Okay, yes, I'm working for OPITZ Consulting as a software developer, software architect for about 15 years, I think. Main experiences in enterprise Java, enterprise web development, and now since a year or so in mobile development, especially mobile web development. As I said, I'm working for OPITZ Consulting. We are a consulting firm here in Germany with about 400 employees and 8 offices, I think. And if you would like to know more about OPITZ Consulting, you can talk to me or look at our website. So it should be fine for now. What about you? I expect you're all JavaScript developers. Anyone who's not a JavaScript developer? Okay. Okay. How many of you have already written a single-page web apps? Okay. So that's a good starting point. So this talk is about the development of testable and maintainable JavaScript web applications, and the emphasis lies on testability and maintainability. And that's the reason we choose the design patterns we look here. We choose very concrete frameworks for the examples that I will show you. But they are not exclusive, the only possibility. Matthias will talk about Backbone, I think, in the next talk, and will show you other possibilities, how you could implement these best practices I will talk about. We do have a little sample app developed by my colleague Tobias Bosch, Tigbro, on GitHub and on Twitter. Our sample application is a to-do application. I think the new Hello World application for single-page web apps and JavaScript MVC frameworks seem to be to-do applications. So you can make a little new line in your list of to-dos. This one will be stored in OpenKeyVal. It's an open source service, a key value database where you can simply store data. You can slide to the settings dialog where you can enter the registration key for this key value store. You can mark them as checked, and that's all. Okay. So this will be the sample application that we will use to demonstrate the concepts. Okay, first of all, I would like to talk a little bit about software design for architecture for web applications. Here we have the old Web 1.0 architecture. We have the browser rendering the HTML, sending requests to the server. There we will have model view controller in that kind that here is a controller which gets the requests, sends them to some backend functionality which will return data. This data will be provided for some kind of view framework, Java server pages, for example, or any other server-side templating framework, which will generate the HTML and send it back to the browser. So from regard of the browser, it's classical request response feeling. And we do have model view controller, but we do have here. We have the controller, some kind of servlet or any other functionality that can process requests. The model is represented by the backend, and the view is some kind of server-side templating framework. These architectures can be enriched with some kind of AJAX functionality, maybe Web 2.0. For example, you have some kind of framework that will, hidden for the developer, send AJAX requests to do partial page reloads to scroll in a table view or in a table without doing a complete request response. But you will probably get partially rendered HTML from the server back to the client, and this AJAX framework will update the DOM with this fragment of HTML on the generated on the server side. The evolution goes further with this kind of architecture, where you have a so-called single-page web app, where you do initially load static HTML, JavaScript code from a web server to the client, and from then on, the client and the JavaScript code on the client will do AJAX requests to the backend, will get data back from the backend, and will update the view. And you do also have a model view controller, but in this case, completely on the client. So this is more client-server paradigm than multi-tier paradigm. And the design patterns you use here are more similar to desktop development, to Swing development, or something that you would do on the client side, on the desktop side. And you will do some kind of remote communication. In the case of JavaScript web applications, you would probably do JSON calls to REST calls to a backend and communicate via JSON, JavaScript object notation, to transfer the data and to update the client. This gives a lot of possibilities, especially our sample application is a mobile application, and this kind of architecture allows you to, for example, wrap this kind of JavaScript client in a container and make it to a native app, like PhoneGap does it. Or you can write an application that can be possibly offline and use HTML, data storage, local storage on the client side to work offline without any backend for a couple of times. And what I would like to talk is about some parts of the design patterns that you can use to develop this kind of client. You would probably use some kind of UI library to design your UI. In our case, we use jQuery Mobile. Jörn introduced this jQuery project. It has some kind of unique features, especially this progressive enhancement of the markup that you write as a developer by the jQuery framework, which responds to the capabilities of the browser that will render this UI, which leads to a broad variety of browsers supported by jQuery Mobile. So you can use jQuery Mobile on iOS, on Android, on Windows Phone, I think, but also on Windows Mobile. So you have a quite broad range of supported browsers due to this architecture of taking semantical HTML and enhancing it with regards to the capabilities of the browser. Okay. So this was our sample application, and I will show you a little bit of the markup that is needed to create such a view. We already have seen this data role tag. It's an HTML5 attribute that is not interpreted by the browser, by the rendering engine, but it can be interpreted by JavaScript. So you can use it to store custom data in this data / tags. Every attribute that begins with data / is ignored by the rendering and can be used by your frameworks. And jQuery Mobile does extensive use of this data tag, data attributes. You can use this divs for a page. Then you have a data role header, and this is your semantic HTML markup, and this is the enhanced result for, in our case, iOS, I think. You have a content part. You have this form here with input forms. And you have this this table view in iOS speak. Here's a little mismatch of the snapshot and the code, because here are 2 lines and the code shows only 1 line. Okay. So that's quite easy markup. Now the question is, how do you get this bound to the backend? Before this, I would like to remind on this progressive enhancement, this DOM transformation that's done by jQuery Mobile. So for example, this snippet of simple semantic HTML code is transformed to more or less something like this by jQuery Mobile. In this case, for the iOS browser, you see this classes that are added, and on some places there are spans added where these classes can be put on, and there's quite a lot of magic going on in the background during this enrichment process. Okay, and we have to keep this in mind for the second part of the talk. So now, how do you get data filled in this markup? Think of some kind of JavaScript functionality that will do a AJAX call to the backend and get a list of to-dos, and you would like to update your markup to show all the current to-dos in your list. And one pattern that you can use for this is data binding, especially two-way data binding, so that you have a framework that automatically updates the view when the model changes, or changes the model when the view changes. If you do some kind of binding by yourself, then it would probably look like something like this. Here, jQuery Mobile is built upon jQuery, uses jQuery, so we will use jQuery in this code snippet also. We register on the submit event for our form and prevent the default action. We don't want the form to be submitted to the server. Instead of this, we call a function add to do. This is for adding a to do. This function will read the data. It will especially get the input text that was entered in the input field. It will get a handle to the list of to-dos, will count how many items are in there, and then it will append a new entry based on what was entered in the input field. And this is here done by hand. So we have a small helper function that will simply return the string of the HTML markup. Of course, you could use some kind of templating mechanism that will extract the HTML code from the source code. Then you trigger a create event. That's the event that causes jQuery Mobile to do this enhancement and to update the markup that will be actually shown by the browser. And then you clear the input field. Okay. So if you look at this chunk of code, it's quite a lot of code. And if you imagine that you will implement more functionality like this, then there will surely be code duplication, which has to be removed. And one great problem with this kind of code is you can't unit test it independently from the UI. If you would like to test this kind of controller code, then you need an input text in your HTML setup, in your fixture. You have to make sure that there's a to-do list which will be modified, and you have to check the modified DOM afterwards to assert your assumptions. So that's not easy to unit test controller code without the UI in this kind of programming style. So probably this would be better. You have some kind of to-do controller object. This object has a list of to-dos and an input text, which can be bound to the UI components, or should be bound to the UI components. And you have a add to-do function method in this case, which should be called when some events occur that, for example, touch return or leave the close the hide the keyboard. Okay. So and this should simply modify the model. In this case, it's the list of to-dos, and everything else should be done automatically. Okay. So there are quite a couple of JavaScript frameworks out there that do exactly this for you. We have chosen AngularJS. AngularJS is a quite complex framework, big framework. It's not a small solution for a small use case, but provides a lot of functionality. It's more like a framework than a library. It provides a kind of container for your application components that will be controlled and triggered by AngularJS. And of course, this is a characteristic of this framework. This can be discussed, or if it's good or if it's bad. So I don't want to discuss this. It's just a sample of a framework that does this data binding. So I won't talk much about this framework features. It provides model view controller support with dependency injection. I will talk about this later. It's the means by which you can inject backend functionality or your backend calling functionality, the code that you need to access your backend into the controllers, so that these are decoupled. What I will show you on the next slides is this two-way data binding. And Angular uses UI templating. It's more or less an HTML compiler on the client side to achieve this two-way data binding. So keep in mind, Angular will also change the DOM to update the view. It has to. And jQuery Mobile, on the other hand, does also change the DOM to do this progressive enhancement. So keep this in mind. Okay, two-way data binding. What is it about? We do have the DOM on the one hand side, and we do have the controller on the other hand. This controller does have our property to-dos, a list of to-dos, and the property input text for the form field. And what we would like to do is to bind between them, read, write, update the DOM, watch for events on the DOM, and the same on the controller side. So for the DOM side, it's more or less easy because we do already have all these events which we can register on and which we can observe. But on the other hand, our to-do controller is a simple JavaScript object, and we don't have any kind of property change mechanisms built in JavaScript. Probably this will change in later revisions of ECMA, but currently we don't have a standard mechanism to watch for change events on JavaScript objects. So that's a feature that's provided by AngularJS. Mainly simplified, it creates a scope object for an object. In our case, this will be the to-do controller in our example. And Angular will create a scope object which will monitor and control this object. And you can get information from this object by expressions. You can set informations, and you can watch for changes. You won't do this frequently by yourself as a developer. These are basic functionality used by Angular itself to achieve this data binding. Okay, how can these expressions look like? For example, you can say $get input text, and you will get the value of the input text property of this thing. You can do something like get todos.length, and you will get the length of the to-dos property of this object, and so on. So I will show you a little bit of very simple code, not from our to-do example that demonstrates this a little bit. So we do have this. Can you read this? Okay, no? Okay. So we have a very simple HTML file. We include the Angular library and a self-written controller.js, which I will show you in a couple of seconds. Then we have this body. This body has an ngController attribute, which instructs Angular to create a hello controller object and establish a scope based on this hello controller object. This hello controller object is implemented here. I will take a look at this in a second. So this will create a hello controller object, we'll wrap it in the scope. And then we have a feature enabled which is called ngAutobind. So what Angular will do, it will bind this input element with name username to this property, username of the controller. And it will bind this function expression to a call of this method greeting. And what this function will do, it will return hello username, or I don't know your name, depending on the state of this username property. So that's all of the code. I will open it here in Chrome. So and now this auto-bind mechanism of Angular will cause to simply update this this DOM. Okay, so that's this kind of binding the markup, the HTML markup, to the controller code of your JavaScript controllers. Okay, for our more complex example, it looks more or less the same. This was our markup. This is the controller code. And now you could establish this binding by bind this initial div with role page to the to-do controller. This will create this to-do controller scope. Then this input field is auto-bound to this property because of the name match. Then you have a div augmented with this attribute ngRepeat. This will bind this part of the expression, to do in to-dos, this with the property to-dos, and it will create a so-called repeater scope, which repeats over this elements of this array. And each element in this array can be accessed by this this name, to do. So in this div, you have some kind of stamping. You will repeat this markup in this div for each element of the to-dos array, and you can bind to the properties of the elements in this array. Okay. So that's quite nice. It will reduce lots of your code. So we are almost done, but there's one problem: the DOM transformation done by jQuery mobile on one hand side, and the DOM manipulation done by AngularJS when it updates the view or every time the model changes. And this needs to be coordinated, because, for example, you can implement multi-pages in jQuery mobile, which contains several divs. Each div is a page, which is more or less prefetched from the server. But the enhancement is only done for the current shown page. And as soon if you do a transition to another page, at that moment, this enhancement of this second page will be done. On the other hand, jQuery Mobile, AngularJS will control the complete HTML document. So this has to be coordinated, for example. So my colleague Tobias Bosch has written a jQuery Mobile adapter, which does exactly this and coordinates these functions. Additionally, it has some extensions for web development, which are quite nice to have when you develop web applications. It's open source on GitHub, but that's one of the main drawbacks. For example, if you use something like AngularJS in combination with some other framework that modifies the DOM. So you have to keep in mind how to coordinate these things. Okay, that's the first part of the story, how to bind the UI with the controller code. Now the controller wants to talk to the back end. And what we already have achieved is that we can test the controller code independently from the UI. What we probably would like to do is to test the controller code independently from the backend code, from the code that accesses the backend. And probably also we would like to test this backend code independently to simply test the communication to the backend. So what would be nice in this case is to have this controller, and for the case of unit testing the controller, you would probably like to create some kind of mock object representing the backend access code, but which behaves as you would like to in the scope of your unit test. So this kind of mocking and stopping and replacing complicated infrastructure by mocks, which you can control in your unit test code, is quite a common practice. And which helps you doing this is the dependency injection. Dependency injection is very well known in enterprise Java. It's, for example, in the Spring framework or Java Enterprise Edition, Common Dependency Injection, CDI standard is very well known there. It's mainly a design pattern to reduce dependency between components, and it works by delegating the responsibility for creating objects and wiring these objects to an external framework which does this creation and wiring at runtime. And this has to be somehow configurable. And that's exactly what can be done by AngularJS in our case. So here's some kind of pseudocode which shows what probably has to happen in our sample applications. Let's assume you do have a refresh to-dos method, which you would like to call when you would like to refresh your to-do list. And in this code, you have to read the to-dos from the backend. And this read function, in this case, probably would like to show a wait dialog, which shows some kind of spinner during this backend access time. And probably it would like to use JSONP to access the backend to circumvent this cross-domain scripting issues that you can't access some backend service from another server than the one your JavaScript code was loaded. So you probably have to call other code to do the thing you have to do. So how can this be structured to be nicely decoupled and usable? So we have our to-do controller as an object created by AngularJS when it binds the UI to this functionality. This is created with new by AngularJS. And now let's assume that it uses an object to-do store. This object to-do store provides a function, a method read. And itself, it needs a reference to a wait dialog function and a JSONP function. So now what AngularJS does, it provides mechanisms to let these objects be created by factories. And it will then create these dependencies between these objects. So how will this look like in code? Let's assume you already have a JSONP factory which returns this JSONP function, and a waitDialog factory which returns this waitDialog function. Then you can register these factories under a simply string name for Angular. And now you would like to write your own service, your own functionality that can be plugged in our to-do store. So you need a to-do store factory which will return an object. In our case, an object having read, this read function, which is implemented here. So, but for this read function to work, you need this JSONP and this waitDialog. So how can you inject these functions? You provide them as parameters of your factory function. You can then use them here in your implementation of your read. And you have to declare this dependency injection by this special property of an object which will be interpreted by AngularJS. You don't need this. If you omit this, then AngularJS will do an auto matching by name, by parameter name, but that won't work if you do some uglifying and some minification. So it's recommended to explicitly declare these dependencies. And then you can register your new service, to-do store, created by to-do store factory. And then one step further, if you have registered the service and you have this controller, this to-do controller, you add a method a parameter to-do store and declare the dependency for AngularJS. So what Angular will do when it creates this binding scope, it will first create the to-do controller. For this, it has to inject the to-do store object. It will call the to-do store factory method. To call this to-do store factory method, it has to create the JSONP object and the waitDialog object. So it will first call this, inject them in the to-do store factory, will get back the to-do store, and will inject it in the to-do controller. Okay. So that's it. It's probably an advantage to talk in English, that I don't talk too much. So we are very good in time. So probably Matthias will have more time to talk about his stuff. To sum up, the message of this talk is there are quite a lot of useful design patterns. If you would like to know more about this, probably a good read is Adi Osmani, which writes an open source book, Essential JavaScript Design Patterns. It's updated just a couple of days before. It will probably be released as a print book by O'Reilly. So that's a very good resource for further reading. And if you start to write bigger JavaScript applications, you have to have some kinds of decoupling your code, structure your code, make it maintainable, and especially make it testable. And there are quite a lot of libraries and frameworks out there that can help you get your stuff done, but probably too much frameworks. So you have to have some good feeling, meditation, something that helps you to decide which framework to use. Probably the talk from Matthias will give you an overview of a different possibility. I would like to thank all the photographs, and of course I would like to thank Tobias Bosch, who can't be here today, who is the main committer of this Angular adapter. and who has provided quite a lot of input for this slide deck.